Hi everyone, and welcome to this video on VLAN basics. I wanted to go over the informational sheet that I posted for you under modules on VLANs just to emphasize a couple of important parts. A couple of things to take note of is why we need VLANs. If we have a large network, broadcasts can impact performance. So we would typically break up our broadcast domains using a router. Remember, each interface on a router creates a separate broadcast domain. So here, this router, because it has two interfaces connected to other local area networks, those are two broadcast domains. So that's one way we can break up broadcast domains, but routers are very expensive. And often if companies can't invest in routers, they have an alternative, and that is a less expensive switch. So a couple of things about switches. Typically, we can segment via function of the network or applications or maybe even a special project that's being worked on so that devices in the same VLAN only broadcast to other devices in that VLAN. So broadcasts from PC 0, 1, and 2 will only be seen by these three devices, not VLAN 20. So taking a look at the default configuration of a switch, if we were to do the show VLAN brief command, we'll see that by default, VLAN 1 has all interfaces in the VLAN 1. That is our default VLAN. It cannot be renamed, it cannot be deleted. Any kind of layer 2 control traffic, things like CDP or LLDP, those will go across VLAN 1. The other thing to take note of is that by default, each of these switch ports can only belong to one VLAN. The only exception to that would be in the case of communicating between two switches. This interface right here can actually take part in, if you will, communication from more than one VLAN. The way it does that is by creating a trunk port. So I'll talk about that in a little bit. But going back to our single switch here, we are going to change the assignment of our ports that we have assigned here. If I were to hover over this port, you'll see it's FA1, this one's FA2, and this is FA3. And we're going to put those into VLAN 10. So I'm going to get into my global config, interface, interface range, FAO1 to 3. Love the range command. So switch port mode access puts this port into what we call static access mode. And for things like port security that you guys learned about in chapter 2, you have to have static access mode for port security. It's also just a good idea to have that enabled so that trunking doesn't accidentally occur. If for some reason somebody were to disconnect this port and attach a switch, if it's set to static access, it won't try or attempt to go into trunking mode. All right, so switch port access VLAN 10. Now notice what happened. Because VLAN 10 did not exist already, and we know that because when we did our show VLAN brief, these are the only VLANs that we have. By default, it's 1, 1002, 1003, 1004, and 1005. So now that we have entered this command here, it has automatically created VLAN 10 for us. Now I just want to show you something. If I use the do command, do show VLAN brief, I can view the VLAN database, or if I use the do command, I can use any privilege exec command here at this elevated privilege. But you're going to notice something. That VLAN was created, and notice the three interfaces are now assigned to VLAN 10, but it doesn't have a name assigned to it because we haven't created a name for that VLAN. So now, if I want to change the interface range, and I believe I picked 10, 11, and 12 over here. Yep, 10, 11, and 12. We're going to go interface range, FA10 through 12. switch port, mode access. Of course, that's why I usually use the tab. If you press the tab key, it'll spell it correctly for you. And then switch port, access, VLAN 20. Do show VLAN brief. So now we have 10, 11, and 12 that are part of VLAN 20. The other thing that I want to make note of is that the different port numbers don't have to be in sequence with one another, and I'll show you that in just a minute. Notice what happened once I changed that to VLAN 20. It actually puts them into sort of a waiting mode. It's actually part of the spanning tree protocol that will be taught in Networking 3. All right, the next thing that I want to talk about, if we go over here, one of the things that we do have to talk about is if you have multiple switches. So in this particular scenario, I've created 2 switches, 3 PCs on each switch. And notice I don't have them in any kind of order. They're sort of random. The port numbers are in order, but that doesn't matter. I could reassign this to FAO 8, and it's not going to matter. So VLAN 10s don't all have to be grouped together, and VLAN 20s don't all have to be grouped together either. So what I want to show next is the 3 things that have to happen in order for end devices to be able to communicate in the same VLAN. So the first thing is, and I don't want to forget to mention this, is that all switches have to have all VLANs. And you can kind of tell from this topology, obviously, if I'm assigning this switch port right here to VLAN 10, this one to 20, and this one to 10, if I haven't already created those VLANs, they'll be created for me. But where it comes into an issue is if I don't have any ports or devices in a particular VLAN, that VLAN won't be created. And so down here, VLAN 30, we will run into some communication issues in the future when we're using inter-VLAN routing, which I'll create a separate video for. But we will run into issues if we don't have all VLANs on all switches. So a good practice to get into here is to go ahead and just create them ahead of time, and then you can name them, and that will also help. So let's go in, config T, VLAN 10, give it a name, students, VLAN 20, name faculty, and then VLAN 30, and we'll name this admin. So if we go over to switch number 1, our second switch, we're going to do the same thing. VLAN 10, name, students, VLAN 20, name, faculty, VLAN 30, name, admin. So now if I were to do show VLAN brief, I'm going to have 3 additional VLANs on switch 1 as well as switch 0. Notice I don't have any interfaces assigned to any of those 3 new VLANs yet. We haven't done that command. So all switches must have the same VLANs. 3 things that have to occur is all the devices in the VLAN must belong to the same network. So what do we mean by that? Well, that means if I were to assign an IP address, let's say 192.168.10.11 over here, and maybe we'll put 192.168.10.12 here, and VLAN 10 over here should also have a 10 dot address. Granted, we're going to stick with our default classes here. So this is a class C, so they're going to each get a /24. And that's actually really important. The subnet masks need to be the same as well as the networks. So if I were to identify with all three of those IP addresses what my network is, we should recognize that because it's a /24, they all belong to the 192.168.10.0 network, because it is in fact a class C, where the first 24 bits equal to a /24. So the second VLAN, VLAN 20, we're going to assign some IP addresses to that as well. So 192.168, let's say 20.50. And then we'll go over here to 192.168.20.51. And I'm just assigning random numbers. 192.168, let's do 30.100. And so we'll plug them in down here in our VLAN table. So notice how if it's in VLAN 20, it's going to have a network address of 192.168.20.0. If it's in VLAN 30, it better have a 192.168.30.0 network address. So that's what we mean here by all devices in a particular VLAN must share the same network address. Let's see, what else? They also must share the same VLAN ID. So in order for PC0 to communicate with PC2, I need to assign them to the correct VLAN. So I'm going to look at, this is FA01 we said. So switch port, mode, access, switch port, access, VLAN 10. And then I believe I changed this to what, FA08. So we're going to go interface, FA08. Now before I assign that to a VLAN, I just want to show you real quick. Let's go ahead and ping between PC0 and PC2. We're going to put 192.168.10.12. So here's PC2, and it's got an IP address. We're going to go over to our command prompt and we're going to ping 192.168.10.11. So I'm trying to ping from here all the way up to PC0. And remember, PC0 is now in a different VLAN. So if I were to look at our show VLAN brief, we'll see that FA01 is in VLAN 10, where FA08 is still in VLAN 1. So that's why my requests are timed out. So now we're going to go to our back to our command prompt. Our last command was interface FA08. We're going to do switch port, mode, access. Just a shortcut. I don't know if you picked up on this yet or not, but SWO mo ac will do the same thing. That's the minimum number of characters you need for switch port mode access. Switch port, access, VLAN 10. Okay, so now that we've put that into VLAN 10, I'm going to fast forward here just to speed it up. And now if I were to ping between PC0 and PC2, they will ping one another. Now again, if I were to assign, let's say PC1 has a different network. So notice it's 20.50 or 20.0 is the network. If I were to come over and just to show you, for example, if I go to interface FA02, switch port mode, access, switch port access, VLAN, let's put it in VLAN 10 just to see what happens. If I were to ping now to the 20.50 address, you will notice that pings will not work, and that is because it doesn't belong to the same network. That's this first requirement. If they're in the same VLAN, they have to belong to the same network, and 20.50 does not belong to the same network. So just to show you, do show VLAN brief, notice FA02 is assigned to VLAN 10, but according to our topology, it should be VLAN 20. So let's go ahead and change that. And notice I can't put an interface in more than one VLAN. If I were to type, well, let me just show you, do show run. Here's my interface FAO2. I'm in VLAN 10. Now if I change that to VLAN 20 and then look at my running command again, notice it did not add another switch port access VLAN command. It just changed it from 10 to 20. And that's because a VLAN port or an interface can only belong to one VLAN. All right, and then now that we're in VLAN 20, let's try to configure another device in VLAN 20. So I'm going to give this the IP address, I say 51. Okay, and I'm going to ping that. Now, you may or may not expect this to work. If you heard the chapter already, you know that the only way for pings to be able to work across switches that only have one link, we need to make this link a trunk link. That's so that it can carry more than one VLAN. So let's do that real quick. Let's go interface G01. We're going to do switch port mode trunk. That's turning it on manually. And notice it makes the link go to orange. I'm going to fast forward. Now that I have trunking established, and I can show you do show interface trunk, will tell me that I have trunking enabled for gigabit 01. Now notice I only did switch port mode trunk on one end, and that's because of the dynamic trunking protocol, DTP. It picked up on the fact that one end of the link is trunking. And to show you what that looks like, show interface G01, I believe is what I used over here. G01, switch port is the command you can put on the end. Because its administrative mode is dynamic auto, it's going to automatically sense if the other end of the link is in trunking mode or not. And I'll show you on this end. So here our operational mode is trunk. Over here, our administrative mode is trunk. Our administrative mode over here is dynamic auto. And what that does, it negotiates the trunk, and so that's why our operational mode is trunk on both ends. So now that we have trunking enabled, let's see now if PC1 can ping PC3, because they are in the same VLAN. Or are they? We haven't done that over here on PC3, on switch 1. So we're going to go to interface, and I believe this was 10. Nope, I stuck to FAO1. Switch port mode access, switch port access VLAN 20. And we're going to fast forward time there. Now our pings should be able to work. All right, so let's see. Switch ports must be assigned to the same VLAN. And then again, just what we did, if we're using multiple switches, we have to enable trunking between the two so that it can tag the frames going across the single link with a VLAN tag, so it knows which broadcast domain it belongs to. The other thing just to note here is that if you were to remove a VLAN and it has a port assigned to it, then that port basically is no longer functional. So if right at this point I exit out of here and say no VLAN 20, and I look at my VLAN database, you'll notice that FAO2 is no longer listed and no longer available. It's not here under VLAN 1, it's not here under VLAN 10. And notice what happens to the switch port. Even if I fast forward time, it's still orange or amber. So it's no longer a functioning port because it is assigned to no VLANs at all. So at this point, it's much better to first reassign a port, switch port access, and I don't have to do switch port mode access again. It's still there. In fact, if I do show run, Notice it says VLAN 20 is there, but to really confirm if that VLAN exists, do show VLAN brief is the way to confirm if that VLAN physically exists or not. If I go to switch port access VLAN 20, remember I deleted it, so it deleted it from the database as well as the name. So it had to recreate it. And if we go back and look, notice it did not bring back the name faculty. So if I want to bring back the name faculty, I have to go back in and type that in to the VLAN. Okay. So the only other thing that the VLAN basics covers, other than creating VLANs, is it talks about specifically the different modes for trunking configuration. Switch port mode trunk, I'm going to say about 99% of the time is what you're going to be required to type in, and it's going to be recommended that you do it on both ends. So in this case, I think it was G01, so switch port mode trunk. And it really didn't make a difference, but the reason it's important to add to your configuration is so that when you're looking at your running config, you know for sure that that's in trunking mode on this end of the interface. You would obviously have to go confirm it on the other end as well, or do show interface trunk is the command to confirm that you are in fact trunking. I won't make you use dynamic desirable, but some of the exercises will. Dynamic auto is the default. On older switches, dynamic desirable was the default, but now it should be dynamic auto. And then switch port no negotiate is what basically prevents DTP frames from being sent out. So if you want to disable the ability for it to negotiate automatically, you would use it when you know you're in access mode or you know you're in trunk mode. And then switch port mode access is another way to basically put a port into static access mode. So it's a permanent non-trunking mode. And then just to verify the show interface command with switch port on the end is how we verify what mode we're in, operational or administrative. And then you absolutely need to know these, especially for this certifications. If your switch port mode trunk on one end and trunk on the other end, then trunking will be turned on. Do show run. So trunking on one end, trunking on the other end. These two will ensure that you have trunking enabled. If you're auto on one end, desirable on the other, trunking will form. Auto on one end, on the other end, trunking will form. And then the reverse combinations. The only form that will not trunk outside of switch port mode access is going to be switch port mode dynamic auto. Auto and auto will not trunk, and that is a common question that you will see on the certification. Thanks for joining me, and I hope if you have any questions, you'll let me know. Have a great day.